Hello, this is Kaylee Gonzalez with MLC CAD Systems, and thank you again for joining me on our webinar today. We're going to be discussing how we can optimize manufacturing communication with SOLIDWORKS MBD and SOLIDWORKS Inspection. Let's talk a bit about these different options. So MBD is actually model-based definition. This is an integrated drawing-less manufacturing documentation solution. The concept of model-based definition is to organize 3D PMI, which is product manufacturing information, into 3D views to export. We will see how we can publish these to a variety of 3D formats, including 3D PDFs, e-drawings, and even STEP 242 files. The ability to export to these 3D formats, they do actually comply to some specific industry standards that we are seeing, such as the MILSTAT 31000A, the ASME standards, and even ISO standards for model-based definition specifically. Now, SOLIDWORKS MBD is an additional license. This runs inside of SOLIDWORKS CAD. So it's not included in any CAD package. It is an additional license, but it also leverages DIM Expert. Now, if you've never heard of DIM Expert, it's actually been inside of SOLIDWORKS for well over a decade. DIM Expert is in every single version of SOLIDWORKS. This is actually the engine that drives model-based definition. It's actually DIM Expert that creates 3D PMI in SOLIDWORKS parts and assemblies. So this means that you can actually take a look at DIM Expert now if you have SOLIDWORKS. Where MBD comes into play is MBD does further organization, customizations, and the export to those industry standards. We're also going to take a look at SOLIDWORKS Inspection. The intent of SOLIDWORKS Inspection is to balloon drawings and 3D PMI capture that information for first article inspection documentation. Again, this is an additional license. This provides both an add-in for SOLIDWORKS plus the addition of the standalone software. If you are going to use SOLIDWORKS Inspection in conjunction with MBD or 3D PMI, you need to have an inspection professional license. It's the professional license for inspection that actually gives you the support for 3D PMI inside of the SOLIDWORKS add-in, plus the support for a variety of other 3D file types inside of the standalone software. So please keep that in mind if you are going to think of utilizing inspection in this way. So what we're going to actually be doing, we are going to start at the top here. We're going to define 3D PMI inside of a SOLIDWORKS part file. Once the 3D PMI has been defined, we're going to take that file and see how we can export for manufacturing, first article inspection, and if you're not quite ready to go into this drawing-less environment, I'll even show you how MBD and DIM Expert can help you expedite the process of creating 2D drawings. As I mentioned, we are going to be starting on the very top here, defining 3D PMI. We're going to see both DIM Expert and model-based definition working together. As we jump into SOLIDWORKS, we're going to start with this particular assembly. Now, DIM Expert and MBD, they are supported in assemblies as well, which is why I have a couple of 3D views already specified. Now, this has a pretty specific and intricate gear assembly, and so that means that the holes inside of that blue gear plate are going to be absolutely critical in order for those gears to actually line up properly. We're actually going to go through the different items on this gear plate to start specifying all of our PMI information. One of the first things we're going to add is just notes. I'm pulling this from my design library. Notes can be customized. They can even have intelligence built into them. I'm actually linking the material into the custom property for the file. This is going to add intelligence to the notes so that if anything changes, the notes will update. We're less likely to develop errors. SOLIDWORKS MBD and annotation views have a specific notes area that we can place these types of manufacturing or quality inspection notes. We can easily set up how we want the view to look, change the location, and then recapture the view at any time. 3D views capture not only annotations, dimensions, but also configurations and zoom. The next step that we want to do is let's start creating some of the 3D PMI. I'm using DimExpert to create my tolerance scheme. And right now I'm actually adding my first, second, and third datums. I can actually customize these as well using DimExpert functionality to only grab a single hole for that third datum. Now I'm choosing the couple of items that I'm going to start with in order for the system to provide me with 3D PMI. We can see the items in teal have been added based on that criteria. The additional faces in green indicate that those faces have been fully defined or fully toleranced based on the scheme we've added. Inside of my annotation tree, we can view the tree display to show annotations only as opposed to a more feature-based tree. We're going to use our annotation views to start documenting the top view. Now, as we start creating 3D views, these are going to be similar to the orthogonal views that we would do in a 2D drawing. The only difference is we're not having to truncate everything into 2D. We're going to add some basic dimensions, and we can actually at any time flip those dimensions into whichever annotation view we want. This is going to allow us to customize exactly what information is going to be available from a top view perspective. We can set our zoom and then capture the 3D view. We can also specify which annotation views are going to be relevant to that view. Next, let's go ahead and take a look at the front view. We have a couple of items here already, but perhaps we want to just flip the arrows to make them a little bit more obvious on which holes they're specifying. That's really just to click on a couple of those leader line handles. We can capture that front view. Now we may want to add some additional dimensions, such as a basic dimension for that center hole. This was added. We can make changes, additions, subtractions really at any point in time and simply just recapture the view. Also inside of this front view orientation is this bolt circle that we're looking on. I'm actually going to create a second dimension scheme specific for this bolt circle. Notice that DimExpert actually allows us to capture those holes as a pattern. So this is going to guarantee we don't accidentally miss one. We added that second dimension scheme. Those holes have already been toleranced. I'm going to create my own view, my own annotation view. It's going to be parallel to the front view, but those items for those bolt circles are just going to be projected onto that specific view. What this means is I can easily just reference that specific view. I can create my own 3D view as well, say flanged holes, and that annotation is only going to be relative to that bolt circle holes. So it's very easy to customize and add some of our own specific information or items we want to call out inside of these 3D views. Let's talk about the right view. We're going to add some information manually. Now for this location, I want to make sure that this whole face is going to be considered as one plane. This is going to make this actually more accurate. Also, I can add tolerancing directly into my DimExpert items whenever I need. I can continue to go ahead and add some additional location dimensions. Over the last couple of years, SOLIDWORKS DimExpert has actually been enhanced so that it feels very much like utilizing Smart Dimension that we're used to in sketches. We can now just simply choose specific faces or edges in order to grab some of these specific location dimensions. Now, in the case of these angles, perhaps we want to reference an intersection line as the basis to grab an accurate dimension. So I created two intersection lines, which is allowing me to grab this angled dimension. Now, I can really at any point in time customize this as well. Just click on the actual dimension, make it relative to Y, Z, normal to the original selection, or I can even choose a user-defined direction. We're going to leave this on Z, but this does provide us with those exact intersection locations on those fillets. Size dimensions are extremely easy to add. Simply click on faces to add fillets, sizes, or chamfer sizes as well. So we can also manually add information to make sure we call out what is critical inside of our model. Again, once completed, make sure we capture this as a 3D view referencing that specific annotation view. We're going to go into the left-hand side. Now, the designer may have already had specific information available through feature dimensions. Feature dimensions are shown in black and sketch dimensions are in blue. These are already included in the model. They may be something that was added or already included through the design process. But we can really at any time move those into an annotation view. What this actually means for us is we're actually utilizing additional non-dim expert information to create and document these 3D views. So we have all of these feature dimensions that are also included when we capture a 3D view. Now that doesn't mean that we still don't want to have some additional information captured, maybe specific to holes, GD&T, things of that nature. What I'm doing now is this is going to be the inner holes. So we're actually going to take a look at documenting the holes kind of on the back flange from this orientation. I'm going to turn off my feature dimensions so that I can start looking at my dim expert annotations once again. I can even make use of things such as section views in order to make sure I'm grabbing the correct holes and faces. Now I can also add geometric tolerancing to specific holes. This is a very simple process. I'm simply going through and creating my datum reference frame, adding maximum material condition, and I can also add which datums that they are referencing to. This is going to allow us to, again, specify exactly the location for this hole to make sure that they're going to be adequately placed. I'm going to also reference some additional basic dimensions that are going to be available inside of this left annotation view. Now, as we move this back to the left annotation view, we want to make sure that the section view is still going to be active before we actually capture this information. The 3D views that we will use to capture will actually capture the section views as well. So every single time we go back to this, that section view is going to be accurate and intact. SOLIDWORKS MBD has an ability to allow us to see annotation views normal to whichever plane we're pan zooming and rotating. This can also be a very great way to just see exactly what items are being referenced or to make sure everything is going to be in the correct view. This particular file actually has some additional configurations. We can actually copy the existing scheme, everything that we've done, and just apply it to a new configuration. In this case, there's a couple dimensions I'm deleting because they're no longer applicable, but this is an extremely streamlined method of being able to utilize existing work for additional configurations inside of the model. I have a new write version for version 2, and I was able to complete that 3D PMI. We saw several methods of creating 3D PMI. It's a very fast, efficient way to apply this information, whether it's through dim expert or feature dimensions and using annotation views. Now that this has been completed, we're going to take that single file that we just created all that information in, and we're going to see how we can export all of that for manufacturing. The first example we're going to see is publishing all of this information to eDrawings. We can choose all of the different configurations to be exported. We can also choose to export a Step 242 file. This is going to be something that manufacturing can utilize for example, CMM or CNC software. We can choose to also add a password in order to specify protect intellectual property. Once we click OK, SOLIDWORKS is going to go through and capture all of this information and then go ahead and dump this into eDrawings. Now, eDrawings is actually going to allow us to see all of those 3D views that we just took that time to create. Not only that, but the viewer of this file, they can actually see dynamic highlighting as far as which components or features those specific dimensions are actually referencing. This actually clears up a lot of ambiguity or questions as far as what specific dimensions are referencing. Not only that, but we can also still pan, zoom, rotate in a very 3D-like environment. When we exported this to eDrawings, we also included that Step 242 attachment. Now we can either view or extract this attachment. The extracting will allow this to be a separate file that can be used for any type of machining. But if we just want to view it, we get a good idea of what exactly is included in this STEP 242 file. And we notice here that we get all the same 3D PMI plus the text from those notes. So again, attachments can absolutely be included inside of the model-based definition export. The second method that we're going to utilize to export all this information is through a template via 3D PDF. Templates can be customized inside of MBD. From there, once the template is customized, created, and selected, we can choose which types of views we want to be exported. And we can also leverage custom properties from the model to include inside of the template. This is again going to really save time, but also make sure that there's no errors. The information between model and document is going to be updated and identical. We can also attach the 242 file even through a 3D PDF. As SOLIDWORKS exports this, it's going to go through each 3D view and then create this very nice 3D PDF for us. We're going to notice in the upper right-hand corner, a lot of that custom property information was populated, as was custom property information in the approvals table. We also have the ability that we could manually add comments in here as well. Along the bottom, we have all of those 3D views with those annotations that we spent all that time creating. This allows the recipient to snap to the correct orientations very fast, very efficiently, plus they can still pan, zoom, and rotate in a 3D-like environment. Now, what's also important to understand here is that this is the free Adobe Reader. This is not an additional purchase. This is through the free Adobe Reader that actually already supports this type of 3D export. As we take a look at these views, we also notice that there's some built-in functions from Adobe, such as being able to do cross-sectioning, changing lights and visualizations, maybe transparency. We also have our model tree that we can also take a look at, and we can access any attachments in this 3D PDF. This is where we can save that STEP 242 file for machining or manufacturing, or open it as well. These templates can be multiple pages. What we're looking at here is page 2, where we have an independent viewport. We can actually choose to look at specific views. They're not connected to anything, but this really allows us a little bit more hands-on, pan, zoom, rotate, and looking at very specific items inside of the model. So again, some great information available to us by being able to export directly to a 3D PDF. So we saw all of that 3D PMI exported to both e-drawings and 3D PDFs for manufacturing. We saw dynamic highlighting plus the STEP 242 files with all of the exact same information. The next step we're going to do is taking all of that PMI information, and we're going to generate a first article inspection report from it. We're going to start inside of SOLIDWORKS Inspection add-in. So we are right back inside of SOLIDWORKS. One of the first things I'm going to do is start a new inspection project. I can choose my template, which is going to include things such as my base tolerancing and how custom properties are mapped. I can update custom properties at any time, pulling information directly from the model. Again, the concept here is pulling as much information, reducing as much error as possible. Now, I'm actually going to choose a manual selection method in order to generate this using PMI. And I'm going to make sure I'm on my all DIMS view. The reason why I'm doing a manual extraction process is because I'm going to be able to drag a box around items that I want to capture. This is going to prevent me from capturing too much information. For example, in the background, there are feature and sketch dimensions that inspection could potentially capture. We don't want that. We want only the items we have gone through the effort to specify to be included in our first article inspection report. We can see that our characteristic tree and inspection has already been populated. Everything has already been included there. We can also choose to include the notes block. So that's also something that can be included and is supported in SOLIDWORKS Inspection. Once I've chosen what I want to be included, I can then go through and let SOLIDWORKS Inspection add in the balloons. Inspection is going to go through each 3D annotation and it's going to add balloons through each dimension that we called out, and that's inside of our characteristic tree. This is also going to allow us to see it. We can snap to those locations even through multiple views. It's a great way to help navigating through the part so we can view those dimensions and make any changes to their specific properties. If I go down to the bottom, we have our note. Now, notes can have pertinent information on how something is going to be either manufactured or inspected. So we want to make sure that the notes are actually going to be correct. What I'm doing here is I'm actually going through and creating my own specific line items based on pertinent information for either quality or manufacturing. Every line item will then have its own balloon or characteristic number. So this is a great way to make sure that we have that accurate balloon information characteristic number for the critical information in notes. As SOLIDWORKS updates the project, we can actually see all the additional line items that have been included. Now, if we want these all to have shared balloon or a non-shared balloon, we have grouping and ungrouping settings that we can make use of as well. Now, once we're ready, we can export this to Excel. What is going to be exported is all of the custom property, inspection project, and characteristic information that we captured. Right now in SOLIDWORKS Inspection is just pulling all of the balloon information and it's consolidating it inside of our first article inspection report. This is an example of what our first article inspection report can look like. We have all of those dimensions, the datum reference frame, basic dimensions all show up exactly the way we expect. We can also make use of this in the inspection standalone product. We can make use of custom properties built into some of these 3D files in order to populate our project. Now, this is that same SOLIDWORKS file, but I'm not seeing my 3D PMI. I actually have access to all of those 3D views that I created, even though I am in Inspection Standalone. And again, I can click on any of those views and captures and view this in a 3D environment. The extraction of these is actually ridiculously simple. I can just right click and say extract all, and this only takes seconds. So from here, we may have a couple of things that we want to simplify. Maybe we want to add some additional line items for instance counts. We can go through the characteristic tree and do some very simple cleanup of the documentation. But this here is reducing our first article inspection time by massive amounts because the bulk of the work is done. It's completed. Inspection also has abilities to update the model through some CAD revision schemes. We can simply replace files with new revisions and not lose any of this work. What I'm doing here is similar, making sure my notes are exploded adequately. And once we have all of our characteristics set up, we are going to be ready that we can actually start exporting this to Excel as well. So when I go into Excel, we actually, through the standalone product, have the ability that we can add snapshots from the model. These are actually referencing all of those specific 3D annotation views and captures that we had. This is going to allow the system to create these screen captures for us. Again, it's taking that manual process out of having to include those inside of our first article inspection document. We can see here what the first article inspection document again is going to look like. Very similar to the first as well. Everything is beautifully formatted and everything is going to be exactly the same as it was inside of the 3D model because we used a lot of the automatic extraction capabilities. The additional tabs along the bottom show us those snapshots that were automatically generated for us with those specific balloons. So we're seeing a lot of automation and a lot of leveraging of 3D PMI even into first article inspection reports. So we're seeing how we can take that 3D PMI and guarantee manufacturing and quality are going to have the same information. So we saw how we can create first article inspection reports through both the add-in and the standalone inspection products. Now, if you are not quite ready to go into this more drawing-less environment, and you still are creating 2D drawings, we can still utilize model-based definition and 3D PMI in order to grab and generate the information for 2D drawings. That's what we're going to take a look at here. So as I go back into SOLIDWORKS, I'm going to go ahead and start a brand new drawing. SOLIDWORKS populates my template, my sheet format, but as I look in my view palette, notice that I have not only all my original orthogonal views, but all of my 3D views as well. This is going to make it extremely fast and efficient to leverage that information even in a 2D environment. As I go into Sheet 2, now that my cover page was corrected, I'm going to make sure my DIM Expert annotation checkbox is turned on. What this is going to allow me to do is when I drag and drop information into my drawing, all of that 3D PMI, that's already organized and it's going to stay organized. And everything inside of the drawing, it's already set up, it's neat, it's organized. It makes it very fast and very efficient in order to start adding this information. I'm going to add one more view here. Now, remember that we had a couple different annotation views for that particular front. We have the center holes, but then we also have the bolt circle. Well, we can still utilize specific drawing views such as a crop view in order to make this more traditional to a 2D drawing. I can also create section views, detail views. All of those items are fully supported. What I'm going to do with this section view is I'm actually going to copy it over to my third sheet. And from here, remember we created that inner holes annotation view, and we can simply direct that into the specific views we're inserting. This makes the creation of these very fast, very efficient, and the views are all going to be identical to what's existing in the 3D model that our designers are looking at. And we can also compensate for multiple configurations. I don't even have to worry about changing the configurations or adding or changing any of the dimensions. Again, that's something that's already set up for us inside of our views. So I was able to create the beginning of our drawing packet, again, in just a matter of minutes because so much work has already been generated for us in those 3D PMI and 3D views. So we covered a ton of information. We saw how we can define 3D PMI using DIM Expert and MBD, and then how we can take that single source of information and export it in a variety of ways for documentation. We can export it for e-drawings, 3D PDFs, and then multiple ways using SOLIDWORKS Inspection and 2D drawings.